Good afternoon. I'd like to just provide a high-level planning framework for edge computing. It consists of 5 different, very interrelated topics. We'll start from the bottom and talk about locations, then the platforms to be housed in those locations, the use cases that are drawing quite a bit of interest in terms of putting them on the edge, and then really one of the really important items that I've encountered in the last couple of item is a difficult one. But if it's not putting to complete the planning framework, we're going to get stuck, we're going to get delayed, and we're going to stall. And it deals with the organization and the transformation and the culture. Okay, so let's start with some very simple physics. Location determines the delay and the latency where the resources are being consumed. So if I'm on premise and my compute and storage resources are there, that's as close as you can get. And that's where my data is going to reside, that's where my processing is going to reside, and so forth. As you move away from your location onto an edge or an access or a data center or a cloud, then the distance to the consumer of those resources will determine by physics the latencies. Okay? So when we look at this in terms of the operator space, you see the laws of physics created the need to put a lot in central offices in locations like where I come from in the United States, determined by the physics of the copper loop, right? So thousands and thousands of central offices. Again, subscriber distance from the location where that is very important. Now, if you look in the European side, one central data center in terms of hundreds of kilometers is a very different scenario. You could serve that with small latencies. So when we look at locations, there are various things from a planning framework that we're advising, and a lot of this work was a result of collaboration we did with a couple of operators. So first thing, physics again, size, space, power, cooling capacities. How much compute resource, storage resource can you put in a constrained environment? Okay. Next thing, when we get to use cases, there's a certain criticality that needs to be factored in from a location perspective. For example, in Denver, a couple weeks ago, somebody says, I'm very skeptical of doing telesurgery. Imagine if you're having surgery done and your central office goes dark, and that's where your resources are. Can a neighboring location take that over? Can a neighboring cell tower pick up those resources? Okay, so criticality of the specific resource utilization needs to be factored from a redundancy perspective. Another important piece around location is security. Security, physical security, data security, privacy, network security. There's a lot of threats these days. And so location is the base level things. How are these locations connected? What transport capabilities do they have? What bandwidth, what specific topologies are in play that add to their overall resource access latency? Okay. The next layer in our 5 related topics is platforms. And just giving you a couple of views here. From the enterprise edge, there's an open fog consortium that's providing reference architectures for their edge. Okay, so instead of cloud, they call it fog, but it's the same principle. And there's some interesting pieces in this reference architecture that deal with analytics, they deal with data, and obviously security. On the Etsy multi-access edge computing, there's some very interesting service provider interfaces around locations around bandwidth management and so forth, right? Underneath, there are a whole bunch of communities that are being referenced here. Acrino, Edge Stack. If you have a platform that is trying to provide low latency services, probably should have some very deterministic capabilities, real-time capabilities. Is your hypervisor able to do a very predictable latency, right? So lots of these communities are in flight. There's Mobile Edge X as well, the Open API. The good thing about these two sides is there's appeared to be an acknowledgement that the important piece to maintain is a common API across both of those. Common API set around the Open API initiative, right? So all of these communities are trying to accelerate the adoption and the capabilities for these platforms, but at the same time, there are commercially available platforms in production today that can be used, whether it's in a private cloud environment, or some of the other ones that can be put into one of these edge locations. So the commercial cloud platforms, they don't wait for standards. They don't wait for communities. They just build and go. So again, that concept of acceleration. So at Intel, we're very much aligned with these community efforts. We have a program that not only tries to unite our members, but also tries to address to some degree the education aspects of the organization, Network Builders University, for example. So we are, I think, in our 5th year for this program, and it is about the communities, it is about collaboration, and it's also about setting specific pieces that we provide into motion, okay? We're a component supplier. We have processors that can go in the enterprise edge around the universal CPE concept that seems to be growing in terms of adoption. Our system on chips, for example, are good for not only the enterprise edge, but also access and other types of service provider edge locations. We also have accelerators. We have specific SDKs and libraries for video and media, which is to address what kind of content you're going to keep in these locations and so forth. And so as a silicon supplier, we try to provide these abstractions to allow our ecosystem partners to take these and make products out of them. Okay, the next interrelated topic I'd like to discuss is the use cases that will be housed on these edge locations. Just about every industry and every vertical has some type of attachment to a low latency capability, whether it's factories with the aggregation of all their sensors and the analytics and the actions to be done on those sensors, hospitality and retail in terms of user experience, transportation and automotive industries, lots of hype around autonomous cars and the ability to process those, smart cities, security as a service, surveillance. All of these industries have some type of initiative around edge computing. So to illustrate, now we bring 5G into the picture. Some of these groupings of use cases around ultra-reliable, low latency, and massive IoT, and enhanced mobile broadband, they will not be able to be fulfilled without some type of edge infrastructure. Okay, so 5G really needs the edge. Similarly, looking at the other side, again, we talked about location, we talked about platforms. The edge enables some of these 5G use cases. The physics, the locations, right? The propagation delays, the security aspects of it, the economics, whether it's a save money or a monetize my investments scenario, those things are all around the enablement of these 5G use cases with edge computing types of installations and deployments. The other important item is data sovereignty, right? This is as close as you can get to the ones that are generating the data and the ones that need to protect it, right? With that opportunity, though, comes a lot of responsibility to protect that data, protect that privacy. So the edge does enable these 5G use cases, and I think when you put these two things together, I heard there's a lot of inertia today to get these things going very quickly. All right, one of the 5G examples, I think in fact we have a demo in our booth, is around gaming. Virtual reality, mixed and merged reality, whether it's for entertainment or for other types of applications that use the same type of technologies around video, around the user experience and so forth. These things are really not possible if the resources are located too far away from the consumer of these particular applications. Okay, so talked about locations, we talked about platforms, we talked about use cases and the user experience. What we think at Intel is that the best way to serve up compute and storage types of assets is through some kind of a cloud implementation. Okay, question is, where are you going to put it? How far away? How close? How much can you fit inside of your physically constrained locations? So we think it's going to drive a distributed multi-cloud type of construction principles. In the beginning, there'll probably be a mix of physical types of appliances with these cloud types of infrastructure. Okay, the next related topic deals with business models. To illustrate this, I'd just like to refer to a study that was done, co-sponsored by Intel last year, just to paint a scenario, a continuum of possible business models. And so STL Partners provided this white paper, and it looks at a continuum of options for the communication service provider. On the very left side of this continuum is the communication service provider as an enabler, co-location in their buildings of infrastructure. Okay, the concept there is somebody else is doing that work. There was an example in our panel yesterday where the gentleman from Akamai says, we've been co-locating for 20 years. Okay, so that is just one side of the spectrum. As you go to the right, the models involve a lot more doing by the operator, right? In the middle here, what you see is the operator as a system integrator. The study looks at simplified return on investments, risk models, revenue models, expense models, and investment models. And again, just to paint the picture, to allow the planning process to take a direction. Pick a spot, either put it into a time element, we're going to start here and go there, or maybe try several of these at the same time. So again, business models vary. Sometimes you want to go to the far right in a consumer digital experience type of an offering where it's a very content-rich experience, very context-aware, and so all of the latency benefits really contribute to the user experience. In the other piece is an enterprise business-to-business case. So this paper is available on our website. Again, very simplified models, but to illustrate some of the options in terms of how am I going to take these use cases and build up an edge infrastructure and expect my operation to make some money over time. Okay, again, simplified. Right, the most difficult and the most challenging of these 5 layers is the technology-driven transformation. Okay, I heard a lot of buzzword bingo this morning in terms of agile processes, in terms of fail fast, in terms of, succeed fast. Are the business processes in the organization aligned to address the business cases, the business models, the use cases, and the particular technology choices that you've made? Will you reward somebody for failing fast? Will you be able to take your aspiration into operation and make it work and manage it over time? This takes a great deal of organizational transformation, and that what I heard this morning is there's a lot of cultural elements that take a long time. The question I have, do we have that much time? Right? What is your specific compelling event and your urgency? Okay, so again, I believe that the organization design principles around doing things small pieces at a time, learn from them, iterate, try again, reward the failures, reward the successes, and really, really look at the overall cultural elements that need to be in place to make all of this work. Okay. In summary, the network transformation is happening. It's happening slower than most people would want. The edge is not a question of if, it's a question of when. And there should be a set of urgent, compelling events that are specific to your businesses that may drive your organizational dynamics to accelerate these processes and make all of this work. Okay, any questions? Sure. There are projects in the gaming area that we've been involved in, but at the ideation level, not necessarily yet in the implementation level. We've done some things also around smart venues, smart stadiums and things like that, with some of the technologies around our video 3D kind of experiences. Also, some of the activities that we had around the Olympics, the Winter Olympics. Again, a lot of these were attached to the 5G, rollout and the demonstration of capabilities. But a lot of those are in those, I'll be honest, in the ideation stages. Demonstrate capabilities, but not necessarily putting these things into practice quite yet.
Thank you.